Hi friends, be ready for exam revision chapter 12. Let's start. So starting from Rutherford's atomic model, he described atom as tiny, dense and positively charged core called nucleus, and around which negatively charged particles circulate at some distance like planets revolve around sun. To understand the limitations of Rutherford atomic model, you just have to remember two keywords, that arrangement of electron and stability of an atom. Rutherford couldn't explain stability of an atom because according to Rutherford, electron revolves in a circular path around nucleus. But it couldn't help to understand the stability of electrons. So, according to Rutherford, arrangements of electron and stability of an atom couldn't be explained. Just remember keywords. Keywords of Rutherford's atomic model is positively charged nucleus, circular orbits which is negatively charged, and third point is strong electrostatic force. And now you can expand all these 3 points, that nucleus is positively charged and entire mass of atom is concentrated at the center. And second point is negatively charged particles means electrons revolving around nucleus in a circular orbit. And third point is electron is negatively charged and nucleus is positively charged, so they must be held together by some force which is called electrostatic force. So these are the 3 points of Rutherford atomic model. Just remember the arrangement, the source of alpha particle, gold foil and screen, how it is arranged. And here look at the arrangement of lead bricks, thin gold foil, zinc screen and scattering of alpha particles. Now observations from alpha particle scattering experiment has 3 main points and keywords are 3 empty space, concentrated positive charge and very small volume concentration. So now look at this observation, that most of the space in an atom is empty. That was his first observation. Second observation is positive charge in an atom is concentrated in very small volume. That is his second observation. And third one is volume occupied by the positively charged particle is very small compared to total volume. Now talking about electron orbit. Electron revolves around nucleus in a fixed orbit, so they must have some centripetal force which is called Fc, and electrons are negatively charged and nucleus is positively charged. So they are bound together by some force which is called electrostatic force and it is denoted by Fe. So our first step will be Fc is equal to Fe is equal to mv square by r is equal to 1 upon 4 pi epsilon naught q1 q2 by r square, and is equal to 1 upon 4 pi epsilon naught q1 is equal to charge on electron, q2 is equal to charge on proton. So our step 1 is equal to mv square by r is equal to this, and now step 2 will be we have to make subject to v square. So v square is equal to r by m into 1 upon 4 pi epsilon naught e square by r square, and r cancel. So we get e square by 1 upon 4 pi epsilon naught rm. Now total energy is equal to Ke plus Pe is equal to half mv square plus v into q. So now putting the value of half mv square, v square from equation number 1, we will get 1 upon half m into e square upon 4 pi epsilon naught rm plus vq means v means charge on electron and q means charge on proton. Our equation becomes e square upon 8 pi epsilon naught r plus minus e square upon 4 pi epsilon naught into r. So now for easy calculation, we have to multiply second term with 2 in numerator and denominator. So what will we get? E square by 8 pi epsilon naught r plus minus 2e square upon 8 pi epsilon naught r. So denominator will be equal. So we can calculate numerator. Numerator will be e square minus 2e square, means x minus 2x. So our result will be, if x minus 2x will be minus x. So result will be minus e square upon 8 pi epsilon naught into r. And minus sign denotes electron is bound to nucleus. So coming towards Bohr model. You just have to remember three keywords: nucleus, orbits and emission of energy. So first point is central part is nucleus, which is positively charged, and entire mass is concentrated in center. Second point is it has non-radiating stationary orbits, and third point is emission or absorption of energy is possible only when electron jumps from one energy level to other energy level. Now from Bohr model, total angular momentum is equal to nh upon 2 pi. But we know that angular momentum is equal to mvr. So nh upon 2 pi is equal to mvr, where n is equal to principal quantum number. And emission or absorption of energy happens only when electron jumps from one energy level to other. And that is equal to E2 minus E1 is equal to H nu form. So now talking about hydrogen spectrum, you must keep in mind there are two types of spectrum: absorption and emission. So in absorption spectrum, you get dark lines in bright background, and in emission spectrum, you get bright lines in dark background. So let's see what happens. If you discharge hydrogen atom and pass that light through prism, you will get bright lines in dark background. And if you discharge hydrogen atom and pass this line through gas or any other medium, you will get dark lines in bright background. Bright lines means energy emission and dark lines means energy absorption. Energy emits when electron goes from higher to lower energy level. And energy absorbs when electron goes from lower to higher energy level. जिसके पास ज़्यादा एनर्जी होगी वो कम एनर्जी वाले को एनर्जी देगा, मीन्स एनर्जी एमिट करेगा, और जिसके पास कम एनर्जी होगी वो ज़्यादा एनर्जी वालों से एनर्जी लेगा, मीन्स एनर्जी एब्सॉर्ब करेगा. So this is the difference between absorption and emission. And now from hydrogen atom spectra, different series were studied by scientists. But for that we need to know wave number. What is wave number? You know from the picture that here is one crest and one trough, one crest and one trough, one crest and one trough, means total you are seeing 3 crests and 3 troughs. So 3 waves are there. So wave number is equal to nu bar is equal to 1 by lambda is equal to r into 1 upon n1 square minus 1 upon n2 square, where n1 is equal to final orbit and n2 is equal to initial orbit, where r is Rydberg constant equal to 1.097 into 10 raised to minus 7 minutes. Lyman series के लिए n1 1 हो जाएगा. n1 means final orbit. So electron will come from either second, third, fourth and so on. So from second, third, fourth and so on orbits, electron will finally come to first orbit, that is Mn series. So our n1 will be 1, so our equation will be 1 minus 1 upon n2 square, but we can take n2 is equal to n, so our equation will be r into 1 minus 1 upon n square, and we can take r is almost 1 because it is 1.097, therefore, and Lyman series falls in UV region. So now Weimar series n1 is equal to 2. For partial series n1 is equal to 3. For bracket series n1 is equal to 4 and p-fund series n1 is equal to 5. Weimar series in visible light and Gaussian bracket and p-fund series comes in infrared region. So friends, that's all for this video. Best of luck for exam. Thank you.